Okay, good morning. Um, Glad as always if you're able to join me for the live stream. Good morning, that one kid. Nice to see you. Good morning to everybody else, or good, whatever part of the week you happen to be watching the lecture this week. So, week 11, we're finally getting to the short end of the semester, which feels really good. So, I'm going to remind you about the distribution project today when I walk through the module, but that's not till December 4th, I think. But anyway, we do have our one sort of big independent project coming up. It will come up sooner than we think, even though October is just hanging on. Right, today's October 31st. So by next week, you guys will see me in November finally. Anyway. So I'm saying that for myself in part so I don't forget to tell you. I'm going to put a spacer in the later in the live stream today to separate out the bonus material from the regular material. So the agenda that you see in front of you is the regular material. That's the stuff that's covered on this week's lab. And then in discussion last week, we looked at what is a window manager, and I asked you to read about window managers, so I'll show you on the agenda. I'll put a break in the live stream for a couple of minutes so people can find this easily, but at the second part of the live stream, I'll do some toying around with window managers so that you can at least see what they look like from me installing them and launching them and playing around with them. Hopefully, though, you have the ability and the time and the inclination to try this for yourself. Particularly if you're a system administrator, it's nice to know your way around installing and doing some basic configurations on things like window managers. So that'll be the second part. Okay. But the first part is just the regular content. So let me go into the class. Go into the module. Pardon me. So you'll see for the next, we're doing a fair amount of sort of bash related stuff over the next few weeks. So we'll be digging in a little bit deeper on some of the features of bash and how to customize bash and get sort of customized behaviors out of it. So this week is a bunch of bash stuff. So how do we get more out of the shell's features than we've been doing so far? Don't forget that fundamentally the shell is just about us typing commands, and the shell interprets those commands, has them executed for us by the system, and then displays the results. But the shell can do a lot more things than just that. So we're going to, before the semester's out, we'll take the time to kind of look at what are some of the other features of the bash shell and how do we use them. But let's walk through the module before I get into the virtual machine. So we're going to look at the bash specific configuration files. So we've used the vim configuration file, .vimrc. And now we're going to look at, it turns out that bash has multiple configuration files. So we'll look at those and how they kind of happen in the bash shell while we're using the bash shell. We'll also look at some of the built-in bash variables. So bash, in addition to being our command interface, is also an environment that has that stores information for us that it uses to help us out, and we can also add additional information into our bash environment. This is going to be new to most people, but when I say environment, I mean that bash is not just the place that I type in commands, but it's a place where I can store information, where I can create custom behaviors to tailor my working environment, my working setup, specifically to my wants and needs. So we'll look at some of the ways that bash supports that today. And we'll also look at bash's command line history. So it turns out that bash remembers what you type, the commands that you type, and that can be handy because you can actually use bash's command history so that instead of actually retyping commands over and over and over again, sometimes you can just cycle back through the bash history of your commands and quickly recall a command that you typed earlier and have bash re-execute it. It's a quite powerful thing that makes a person a lot more productive when working in text. So readings, there's not a whole bunch of them. We've talked about hidden files before, so some of that will be kind of just refreshing your memory about what we mean by dot files, hidden files. I'm going to pop up the hands-on experiments, and those are there as always just as an assist. So if you can't figure out what you might do to experiment with the new things we're learning in the system this week, the hands-on experiments are there to offer you some ideas. Piazza discussion this week will be about actually customizing bash, kind of like we customized VI by adding additional options. We can customize bash to create additional options inside of it as well. So our discussion will be looking at that this week, and then I'll sort of borrow your more interesting ideas or experiences and then demo some customizations in bash next week. Okay, and then I'm going to stop for just a second on the distro project. So it's due December 4th, and I will open it to remind you what it is. It is mostly doing research on a Linux distribution. There are a lot to choose from. So this list is just a list of some of the many Linux distributions that are out there. So your task first will be to pick a Linux distribution. You might go look at the websites of a few different Linux distributions before you pick one, and then just kind of based on what you see on the website, if it's, nice looking desktop graphics, or that you get a sense that they have a nice supportive community around them, which is the case for many Linux distributions. Anyway, so what I recommend that you do is click on some number of these links, go look around the websites of these distributions, and then from that just sort of basic glancing around, pick a distribution. And then the template here, what to submit. The template here will guide you through the rest of your research project by presenting you with a series of questions that you will then go do research to find the answer on your chosen distribution and fill in the template. I've walked through the template before. I'm not going to do that today, but I will walk through the template again in the next couple of weeks. So look around at a few distributions, pick one, and then go use this template to guide your research and then hopefully ultimately an installation. If you are a UTM user, so apologies for this couple of minutes for those of you who are on VirtualBox, but if you are on a Mac and you are using UTM, your menu of possible distributions is smaller than the rest of us. So let me go look at the UTM gallery. So this is for the Mac users specifically. Now this is what I can see on their website. You might see something different. So when you are doing this project and you are a Mac user using UTM, what are your options? Well, you don't want to use Debian because we're already using Debian extensively in the class. So all the ones that are just labeled plain Debian aren't of any interest to us. So your options are kind of limited, but you could choose this Arch, which is a link. So you could choose Arch Linux, which I'm going to flip back over to the distro project. Sorry if this is... So that's one of the choices. So if you are using UTM, Arch is on the list. It is a good choice, and you have access to one that's already been installed. So you won't do the installation, but you can at least download it, run it, and see what it feels like as a user. You also have Fedora that you could use. I did a short demo with Fedora last week, but that doesn't mean you can't use it for your distribution project. So if you are a UTM user, Arch Linux is a choice. Fedora is a choice. I bet Fedora is even on this list. It is. So Kali Linux, that's another choice that you have if you are a UTM user. That one may or may not be on the list. It's not, but it doesn't matter. As long as it's not a Debian, like a straight up Debian, it is in play. So Arch Linux, Fedora, which is a Linux, Kali, which is a Linux, those are all good choices for the UTM users. I wouldn't pick any of those. And then the last two in the gallery that I see that would be good choices are the Ubuntus. So if you are a UTM user, don't use a Debian. Obviously, I think it's obvious anyway. You won't use a Windows because this is a Linux class. And you won't use Solaris, which is not Linux. React, I don't even know what that is. It's not on my list, but my guess is that React OS is not a Linux. But let's go look. Oh, it is. It appears to be a Linux. Yeah, it appears to be a Linux. So I think you can use that one. All right, so UTM users, and then I'll close this part out. Arch Linux is a good choice for the project. Fedora is a good choice for the project. Kali is a good choice for the project. React is an okay choice for the project. And either one of these Ubuntus is a fine choice for the project. Solaris is not. It is not a Linux. Mac is a Mac. And then, of course, not Windows. And then let me get a question in chat. So... Okay, so that one kid asked, when removing an old VM, it won't let you reuse the name, and that is in fact true. So yeah, so when you go into, let me get to my VM view so I can answer that question. Okay, so there's a related question. I can't make that thing go away. Is it this one? No. Hold on, working on it. Is this... That's not it. I don't want that. Let me make that go away. What I'm trying to do right now, everybody, is get to answer this question in chat, which is a relevant question. Here it is. All right, so I want that. Where is it? Oh man. All right, hold on. Well, I'll just add it in real quick. All right, so this is related because it is related to your ability to create a new virtual machine. So let me get this thing where you can see it. Yay. All right, so the question is, when I go delete one of my virtual machines and then try to create a new one, I get a complaint if I reuse one of the old names. So if I were to delete this Debian clone as an example. So let me see if you can see this. Well, I'll just tell you. So it is true. You can't reuse the names, and I'll show you why that's the case, unless when you are removing a virtual machine. Oh, darn it. I didn't want to start it. Can you see this? I don't think you can see it. Yeah, so I'm going to have to just kind of do this on the fly. So let me get another one here. New source, add source. I got to get the little dialog that popped up. Okay. So when you get this dialog, if you say remove only, you actually don't delete the thing from your system. It's still in your system. So I'm going to do that here. I'm going to say remove only. If you delete all files, you're good to reuse names. Okay, so I think that answered the question. Yeah, so if you delete all files, it literally deletes everything and you're good to reuse the name. But if you remove only, it actually keeps the entire virtual machine on your system, which you could then reinsert into VirtualBox Manager. So I think that answered the question. So I think we can go ahead and leave it there. So, but if not, let me know. Yeah, so if you remove only, it's still in your system and you can't reuse the name. If you delete all files, then it's completely erased from your system and you can reuse the name. Okay, perfect. So I'm told in chat that answered the question. So if you are, I'll go back and just close this thought on the distro project. If you're using UTM, you want to pick one of the Linuxes from the gallery. And if you have doubts that what you have selected is a Linux or not, because not all of these are Linuxes, please let me know and I will confirm your choice or steer you toward a Linux system. So don't use Windows, don't use Mac, don't use Solaris. The other ones in the UTM gallery appear to be Linuxes, so they should all be fine. And obviously don't use Debian because we have been using Debian as a group, and that would not make for an interesting project because you'd be doing research on something that I spent the whole semester talking about. Okay. So now I can close a bunch of stuff and get back to the main part of the agenda. So anyway, look around at the distributions. If you are a UTM user, you should probably make note first of your smaller menu of options. Then go look at, just kind of glance through the websites of the different options that you have to work with. Pick a distribution, do the research that the template down here will guide you to do, and then install and run if you are using VirtualBox, or run if you are in UTM. Get your hands on it, log in, see what's been installed for you, see if the shell looks and feels the same, those kinds of things. Okay, that's all in the template though. The template will offer you guidance for all of the steps that you need to take. Okay, with that, I think I can now return to the agenda, which is talking about initialization files. So this is not super exciting, but it is something that I recommend that you explore, and it doesn't take very long, and it's not going to take me very long to look at the dot files in Bash. So you can't see me yet. Let me switch. Okay, so back to my virtual machine. Yeah, hopefully that's plenty big enough. So let me log in. I'm going to clear. There's a listing. If I list all, I will see what dot files are already here. So the ones that we're interested in right now are the dot files that are bash related. So I have a .bash history, a .bash logout, and a .bash rc. So I don't believe I have ever, let me see when those were last updated. So .bash history is my command history, and bash is automatically producing that. But you'll notice that .bash logout and .bash rc date back to September 5th was the last time there were any alterations to them. So if you're running Debian like I am, it's probably the case that you have a .bash history automatically, that you have a .bash logout automatically, and that you have a .bash rc file automatically. I do not have a .bash underscore profile, and I do not actually, right, and a .bash login. So that's okay. It's just the point here is that when you fire up a new Linux system and you're using bash, you may or may not have any of these files. .bash login, .bash profile, .bash rc, .bash logout, and reminding you that the tildes in front of them are shorthand for these are files to be found in your home directory. So I am in home jboyd-t. So what these files are, just like .vimrc that you see there, .vimrc is read every time the Vim editor is launched. So these files, .bash login and so on, are read at different timings. .bash login is processed by your shell when you log in sometimes, which is a weird one. You'll notice I put a note there, only if there's no .bash profile to be found. So .bash profile is read and processed by your shell automatically if it is present when you log into the system. .bash rc is going to feel funny at first because it is processed when a new shell is opened, which I will do an experiment twice with that today. And then .bash logout is automatically processed when you log out of the system. So how do we observe these things? Well, let's start by looking at the .bash login. So I'm going to create one in my home directory using Vim. So I'm going to vim .bash underscore login. And I'm careful about the typing here because it does matter. If it's not spelled exactly like this, then the shell won't find it. So the shell is looking specifically when you log in for a file in your home directory specifically called .bash underscore login, all lowercase letters. If it's not named exactly that and saved exactly in your home directory, then the shell won't see it and the shell won't process it. So how can we, just as an experiment, observe this file in action? The easiest way to do this for some of these files is simply to put an echo statement in here that echoes an output to that effect. So logging in ... and then I'll just literally type .bash. Is that the file I'm in? Yeah. Login is being processed. So I'm literally just going to have the shell print a message to the screen when it automatically opens and reads this file. If I see the message on the screen, then I will know that, yes, in fact, the bash shell actually saw the file and it processed its contents. So I'm going to save this. Colon, well, obviously escape, colon WQ to write and quit. And then I'm going to exit, i.e. log out of the system. Okay, so now I'm going to log in the system, and what I'm hoping to see is that comment that I just made, showing me that the shell found and processed that file. If you look at the next to the last line in my screen, you'll see logging in .bash login is being processed. So it was in fact processed. So this doesn't work for all of these files, but the first thing to try is, can I put an echo in there that has a message in it and then see the message being printed to the screen. So for .bash login, it in fact worked. So let me clear. It's still in my home, and now I'm going to list everybody. So the note says that .bash login will only be processed if there's not a .bash profile. So at present, there is not a .bash profile. So I'm going to make one, and I'm going to log out and log back in and see if this is true. So vim, I'm in my home directory, so .bash profile, being careful to spell it exactly like that or the shell won't find it. So it has to be in my home directory. It has to be named .bash underscore profile, all lowercase letters, or it won't work. Okay, so I'm going to do the same thing here though. So insert echo processing. Just going to put the little tilde there to remind myself that this needs to be in my home directory. And this time I'm just going to put that much message. So I put this echo statement in here because if the shell actually does what I'm told it does, which is to open and process this file, then it will cause this message to print to the screen. So I'm going to colon write and quit. I'm going to type exit to log out. Now I'm going to log back in. So what I'm told is if .bash profile is there, it will be processed and .bash login will not. So I should see my .bash profile output, but not my .bash login output. And that is in fact true. It says at the next to last line of the output, processing .bash profile, but it no longer prints my login echo statement. And that's because that's what the shell tells me it will do. So .bash profile kind of cancels out whatever .bash login does. This is probably just sort of for historical purposes that these two files are kept around. So if the shell should fail to find a .bash profile, then it will secondarily attempt to find a .bash login. And that's probably because older systems, is my guess, may have the login file version and not the profile version. So the shell just allows either. But if you have a .bash profile, then you don't really need a .bash login, so don't. There's no reason to use it. Let's do one other .bash profile experiment before we come back and do a third one here in just a little while. So I'm going to open it again. I'm in my home directory. So I'm going to open .bash profile. So I'm kind of done with .bash login. I'm going to use the .bash profile that overrides it. Yes, you can. That's an excellent question, that one, kid. So could you do things, pardon me, could you load an alias into this .bash profile and have it added to your environment at the very moment you log in? And the answer is you absolutely can do that. So let's do one. That's a good experiment. And we'll come back and revisit aliases. We've talked about this once, but let's do... I'll make an alias hello, and I will make it be, I'll say, hello, Boyd. Those are single quotes, by the way. So I have single quotes all the way around Cal say all the way to the end. And then I have double quotes around the hello and the Boyd part. So sorry, that's a little bit weird looking. I guess I can add an extra space in there so you can see it. Nah, I don't want to do that. That's just weird. So yes, one of the things you can do with your .bash profile is you can load up your custom settings for your shell, which means that when you log in, your custom settings are there. So we're going to try this alias. Hopefully I got it right. And I'm also going to make a variable for myself. You can also have data loaded up for you. Now this is kind of a silly one, but you can actually store data for your use when you log into the system. So now I have this food variable that will be a part of my system when I log in. So I'm going to write and quit this. We have an alias, we have a variable. I'm going to write and quit. So because I haven't logged in, these settings are not yet available. So if I type hello right now, I get a command not found. And if I try to look at the value of my food variable, it's empty. And that's because these are login settings and I haven't yet gone back out and re-entered through a login. So I'm going to exit. I am going to log back in. And in theory now, because my .bash profile was processed, my alias and my variable should be available. So if I type hello, there's my alias in action. And if I try to look at my food data, there are the enchiladas that I put in food. So that's an excellent point and sort of question slash point to be made, that one, kid, that this is what this is for. Your .bash profile is the perfect place to create all of the settings that you want to be loaded in for you when you log into the system. If any of you are gamers, then this is kind of like your shell loadout. If you want to think of it that way, it would go in your bash profile. Okay. We have a .bash logout, and I'll go ahead and do a quick experiment with that. And then we'll look at .bash RC, which is the weird one. So .bash logout, do I already have one? I do. Let's see what's in it. So when I created my Debian account, the Debian system automatically loaded up some content for my .bash logout. But I'm going to go ahead and add my own at the bottom of it here. So what I want to know is, for example, what happens if I do an echo statement? In my .bash logout. I'll just give you a heads up about this. Because I'm not going to touch any of the stuff that was already there, but because my .bash logout clears the screen, any echo statements I do are probably not going to appear anywhere. But let's see if we see this. But I don't expect to see my logging out message when I log out, and then we'll look at a different way to kind of observe the logout file working. So put that echo statement, logging out. I'm going to go ahead and try it. Yeah, so because it's clearing the entire console, my echo statement doesn't do anything. Now that was what I expected. So how might we view or observe the fact that this logout script is actually working? Well, the thing we can do is we can there. Actually, I won't make it hidden. I'll just say logout log. No, let's make it hidden. The extension here doesn't matter. The .log could be .txt. Linux doesn't care about file extensions like that. But anyway, what I'm doing here is I'm going to take the echo statement and I'm going to redirect it to this file that I'm going to have created called logout.log, so that even though I won't see this print to the screen, I will be able to view my logout log and see that this shell file is actually being processed. I'm actually going to also, and notice I'm using the double arrow redirect to append to the file. I'm also going to put a timestamp there. So I'm going to echo logging out, and then I'm also going to put a timestamp on the bottom of my logout log, so that every time I log out, even though nothing is printed to the screen, things will be printed to the bottom of this file, and then I can go look at the file and see my logouts happening. All right, so there's those things. I'm gonna write and quit. Hopefully I'm not going too fast for this to work for people. I mean, if you're on the video later, you can always hit pause, but hopefully I'm not running past you. So if you're out there in chat and I go too fast somewhere, just please tell me to slow down a bit or to put something back on the screen. I'm happy to do that. Okay, so I'm gonna log out. I know nothing's gonna print to the screen, but what I want to know is when I log back in and clear, so is .logout.log here? It is kind of right half of the screen. .logout.log, so if I use cat just to dump the contents of that to the screen, does it show me that the shell detected .bash logout and do something? It did. So there's my echo statement at the bottom of the file, and then underneath that, appended underneath that, is my my timestamp of when it was that I logged out, which was at 8:34 a.m. on the 31st of October. Okay, so login is stuff that the shell will execute for you when you log in, but profile is profile also does that. So if for my money, I would just use bash profile for any sort of login information that you want the shell to pick up. .bash logout is anything that you want to have happen as you log out. On a sort of very basic system like this, there's not a whole lot I can think of that I would want to do on a logout. But in theory, if you created some kind of a trash folder for yourself, maybe you would have your trash folder cleared on logout. For now, I'm just going to keep a file that timestamps itself every time I log out, and then I can go back and look at that later, just to know that in fact it works. Okay, so .bash rc is a weird one. At least it appears weird right now. Let me see if I have one already. I do, so let's go look and see what is inside of it. A whole bunch of stuff. So, and in fact, it appears that .bash rc has a lot more settings kind of already placed inside of it for me by my Debian system than I even was aware of. So a whole bunch of stuff in here that was automatically created for me by the system. So why would it do this? First thing I'm going to do is I'm going to go to the bottom. And I'm going to add an echo statement and just say processing .bash rc. So I'm going to add this statement so that whenever bash rc executes, I will be made aware of that fact. This one is the hard one to work out in one's head. Until you've worked in a Linux environment where you have a mix of people using a graphical setup and a non-graphical setup. So bash rc, just kind of heads up, it's a little bit weird. It's not as easy to understand as profile is going to get processed when I log in. Logout's going to get processed when I log out. When does bash rc get processed? Well, if not on login and not on logout, then when? So I'm going to write and quit my bash rc file. I didn't touch anything that was there. I just added a new thing, which for me was way down on line 115. So let's log out, log back in, and see if anything about bash rc happens. It does not. So in this environment, all of that stuff that bash rc has in it appears to do nothing. So one way to see when bash rc works in its most basic way is to run bash on top of itself. So from bash, I'm actually right now about to run another bash on top. And you'll notice that now bash RC is processed. So this is unusual because how often do we run a shell on top of a shell? Directly, not very often. Pardon me. So bash RC will be processed when a non-login shell is executed, which is weird. So when does a login shell execute? Technically, when you log in to a shell, a login shell is executed. And then when you run a shell, like on top of your login shell, then bash RC is executed. By the way, the shell itself knows what level of shell you're in at any given moment. So I'm in shell level 2. What does that mean? That means I'm running a shell on top of my login shell. I'm going to exit, and then I'm going to echo shell level again. So your login shell is shell level 1, at least in this circumstance. So if I run a bash on top of it, not only is bash RC executed, but my shell level has changed to show that I'm running a shell on top of the shell. And just because I think it's mildly interesting to do this, let's run a shell on top of a shell on top of a shell. Notice, by the way, that bash RC was yet again processed. And if I echo shell level now, SHLVL, shell level, I'm now in level 3, so I'm running a bash on top of a bash on top of my login bash. None of that seems useful or interesting at the moment. We do have an example where we're going to take advantage of this in the second half of the live stream today. But so that it is all kind of introduced at the same time. When is bash RC processed? When you execute a shell that's not your login shell. That's what all this was about. This is a shell that is not a level 1 shell, and bash RC is processed at that time. I'm going to go ahead and exit carefully. So I should be in shell level 2 now. Now I'm in shell level 1. That's my login shell. I'm stopping. If I exit from here, I effectively log out. Okay, so that's those files. The hardest one to understand is bash RC, but it will make more sense in the second half today when we see it in action, and it will make more sense when we start doing shell scripting where we need these extra shell levels, or we will kind of find ourselves using extra shell levels. Okay, so one more thing on these files. So let's say, for example, that I wanted to edit my .bash profile. So I'll do the same thing. I'll just do a calc. Double quotes around that part, and then a single quote to close the calc, single quote. So let's just say that I want to make alterations to my bash profile, adding new things into my environment. So I'm going to write and quit. But I don't want to have to log out every time. So do I have to log out every time I edit my .bash profile to get the new settings in my environment? And the answer is no, you don't. So on line 14, you'll see the note that says sourcing.files. So you can literally use the command source on the .bash profile, and it will reread it into your environment. So you don't have to log out to get your new settings from your .files. You can use the source command to get those settings. I should have a goodbye alias now. Yep. So you don't have to log out to reprocess your dot files, you can simply use the source command to cause the shell to reread the contents of your dot files. There's a quicker way to do that, which is dot. So the shortcut for sourcing is dot. So if I do dot space dot bash profile, that also will cause all of the definitions inside to be reprocessed. So line 14 on the agenda over there is telling you that you can edit your dot bash profile, process the changes into your environment without having to log out, which is simply a convenience. If you forget, you can just log out and log back in, and the same thing will happen. This works, by the way, for any of your .bash files. So you can use source on any of them to process their contents in, which is also a good way to do experiments on them without having to log out and log in over and over and over again. Okay, so I mentioned that I had created this food variable in my .bash profile, which is a piece of data that is part of your working environment in the shell. The env command, which is the next thing on the agenda, will actually show you all of the data that your shell is currently tracking for you. So one of them is really nasty, but if you just start at the top of my screen and you see xdg seat equals seat 0, xdg seat in all caps is a shell variable. You can actually print it out separately by saying echo $xdg underscore seat, which will show seat 0. But anyway, this env command is all of the active data in your shell environment. So I have xdg seat, pwd log name, xdg session, motd shown, that's message of the day, by the way, home, language, ls colors, which is how the listings are colorified, invocation ID, xdg session class, term, user, shell level, which I have used in this in our session today, and then a few xdg related ones, a journal stream one, a hush login, path, big P path, that's an important one, mail, and then an underscore one. So this data, much of it is kind of created and managed for you by the shell, and much of these are used by the shell in different circumstances. So the shell knows, because of these settings, for example, to show my listings in color. That's part of my shell environment, that the colors come out. That I can say cd home with that $sign, or echo home with that $sign. So that's a piece of shell data, and the shell actually uses that to make my life more convenient. So when I type cd and press enter, the shell automatically knows to go to whatever that home data is, which for me is home jboyd. So we don't need to get too hung up on shell variables until we start scripting, but the idea is that the shell has settings that it manages for you as part of your working environment. It has variables that it manages for you, which is these all capital letters things, that is the data associated with your working environment. We just tried out an alias, which is a way to create a shortcut command customized to your own liking. So the shell has all of these features kind of that are a part of your working environment, and you can set, change, manipulate these settings in those dot files that we were just talking about. Okay, so that's the env, and env is simply what is the environment data that the shell is currently tracking for me, which is all of this stuff, which is not super interesting unless you have a problem, and some piece of data in here helps you diagnose the problem. So system administrator types that command is quite important. Okay, so that's env. So shell aliases, we have one that we created in, I'm just going to cat it out. In fact, I made two. So I created a hello alias, which is a customized shortcut for the larger command, cal say hello Boyd. I also made a goodbye alias, which is a customized shortcut command for cal say have a great day Boyd. We can also experiment with aliases on the command line, so we can actually use the alias command by itself to see what aliases are here. So there's the two that I created, and it turns out that the shell was already configured to load up an alias for ls, which is to do ls's automatically in color, which is a nice touch, I think. But I didn't do that. That was already in my Debian system when I created my account. So you can use the alias command by itself to see what your aliases are. You can use the alias command, this is ll, to create new aliases. So I'll say that ll is a shortcut for long listings. So now that is a part of the aliases in my environment. If I type ll, I get long listings. I can unalias things, by the way. So I can remove an alias by unaliasing it. So if I unalias ll, you'll notice the ll alias is gone and now the command doesn't work. One more thing about aliases. So there's my alias. I'm going to log out, log back in. So the colorify alias is actually gone, and that's because that was in the .bash rc, I guarantee you. So if I source .bash rc, so the aliases are actually created inside of these dot files, at least the custom ones. So the reason why my ll command is gone is because unless I store it in one of these dot files, it will be erased every time I log out. So if I like my ll alias, what I ought to do is put it in one of the dot files. I'll put it in the dot profile one. So if you like your aliases and you want them there every time you log into the system, then load them into a dot file. Yeah, so WQ. I could log out now, but instead of logging out, I'm going to use dot as a shorthand for source, and I'm just going to simply reload dot profile. And now my ll alias is available, but if I do log out, then because that alias is in my .bash profile file, it's automatically restored for me when I log in. So I went through those a little bit quickly. Hopefully, though, there's enough there that you can, hit pause on if you're watching the video later, or that you're able to keep track of while we're working. So yeah, there's aliases, which we looked at aliases briefly very early in the semester, but now that we have the dot files for bash, we can actually create and save our aliases so that they are always there when we log in, which is why we're talking about them today, is because now you can create a permanent alias for your working environment, or many aliases if you like them. Okay. Next item is command histories. So bash automatically does this. You can actually, in your environment, I'm going to do a pattern search for hist. Let's see if that comes up. It didn't. Oh, it was in bash rc though. So there isn't any history in my environment, but I suspect, we'll come back to that in a bit. If you type the command history, you will see that the bash shell is keeping track of some number of your prior commands in a big long numbered list. And you may not see it on my screen, but the last entry line 311 was the most command that I executed. And then 310 was the next command before that. 309 was the next command before that, and on and on. And right now there are 311 commands in my command history. This is useful for two reasons. For one reason, when you're in Bash, you can use the up and down arrow keys to cycle back through your command history. So if I start pressing the up arrow key, I'm going to get to the last command I typed. And if I go the up arrow key again, the one before that, the one before that, if I just keep pressing up, I will see all the commands that I've been typing today, and probably even before today. So I'm still just pressing the up arrow key. So when you're on the Bash shell, you can actually use your up arrow keys to cycle backwards through your command history. And once you get to a command that you like this one, you can press enter on it and re-execute it. Now my command history will have that command as the very most recent thing. And then if I keep upping through it, I will see other items in my command history. You can also, by the way, once you've gone up sort of backwards through your command history a ways, you can use the down arrow key to come back down to the last thing that you did, and then ultimately a blank prompt for a new command. So up, 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 down, 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 down. So that's super, super handy. You may or may not have seen that I've used this on occasion, kind of subconsciously. When I want to get a recent command back, I'll just kind of up arrow to it real quick and press enter. Sometimes I'll go past the one that I wanted, and then I'll go back down and hit the one that I want. So pretty cool. All right, so there's my command history. Another thing you can do, though, if you're viewing your command history and you say to yourself, I want to run command 298, which says source.bashrc. Instead of cycling through it with the arrows, you can actually use the exclamation point and say, I want command 298. If my history, my command history item 298, which is source.bashrc, and it will execute it, which is pretty cool. So now that becomes part of my newer command history, and also notice that 298 is still that same command from the prior time that I used it. Love command histories. One more thing that you can do is, so let's just say command number 282 up there, which says cat.bash profile. I could use exclamation point 282 and get it. I could use the up arrow keys until I cycle back to it. The other thing I can do, though, is I can use two exclamation points, or no, sorry, one exclamation point. And I can say the most recent command in my history that starts with CAT. And the shell will automatically go through my command history backwards until it finds the first item that has CAT on it, which for me will be cat.bash profile. So you can do by number, you can do by pattern matching. Let me dump the history again. So if I were to do bang AL here, it's going to go back through my history until it finds the first command that starts with AL, which for me is number 307, alias. Which is another way to sort of quickly get back old commands. So those two are useful, by number, by leading pattern. The last one is one that I never use. So to get the last command on the bash shell from its history, you can just up arrow to it, which is how I do it. But if you prefer, you can use two exclamation points, and it will run the most recent command. So I'm going to do a more elaborate command just so we can see that. So I can up arrow to that command, or I can use two exclamation points, and it will rerun the immediate last command that I did. I personally never use this, maybe in scripting once in a blue moon, but those are all command history features. Okay, So that's command history. The way to get used to it is, for me, I would say at the end of a session where you're working through content for a lab, then do command history stuff so that you have kind of a command history to play with. Try out the number things, try out the pattern matching thing, try out the arrows, try out the double exclamation points. View the history with the history command to get used to this. And for my money, if you can get in the habit of using the up arrows, you're already going to speed yourself up dramatically. Okay, that's command history. Next item is tab completion. So tab completion is this. If you type a letter, let's just say C, and you press the tab key, sometimes something will happen, but sometimes nothing will happen. But if you press it twice, so I pressed it a second time, it will show you all of the available commands in your environment that start with a C. And so let's just say, for argument's sake, that I want to find one of the CA commands. So I'm going to type CA. I'm going to press tab, nothing happens. But if I press it a second time, it's going to list for me all the ones that start with CA. All right, so how about CAL? Press it once, nothing happens. Press it a second time. Now I'm down to just the commands I have available to me that start with CAL. If I put an E on here and press tab, what that tells me is that there is only one command in my environment that starts with CALE. And by pressing tab, the shell was automatically able to sort of grab the complete. It's called tab completion. Pressing tab allowed the shell to complete the command for me. Interesting. This is just like preloaded stuff, which is weird. Anyway, so you can do this with all kinds of commands. So CL, if I press tab, okay, so clear, it turns out, is the only command that I have available to me that starts with CL. So I will press enter and the clear command will execute. If I type G, nothing happens on the first tab. The second tab gives me the menu of options and like, okay, yeah, I was going for goodbye. So if I type GO and press tab, the only thing that has GO in my command menu is goodbye, which it turns out is an alias. So tab completion is working against commands and aliases, as it turns out. So practice with that as well. Tab completion is super, super, super powerful. Okay, last thing of the regular content, and then I'm going to put a small break in, and then the bonus content, which is window managers. So the bonus content is completely optional, but let me finish the content, and then you all can make your own choices about whether or not you want to watch me do this other thing. So the last thing on the agenda is PS1. So what is PS1? Well, it's in all caps. So at this point of the semester, if I see something presented to me in all caps, I might ask myself if it is possibly some of the shell environment's data, which in this case it is. Now it's very weird looking if I echo it out with a $sign, but what all that stuff is talking about there is how my shell prompt is created. And I can actually override that. So if I say PS1, 1, so PS1 represents the top level shell prompt. PS1 equals hello with an arrow and a space. Now that's my prompt. So you can customize the prompt. And your discussion this week will have you go out and look at how do you do that. Like, what does the \U mean? And what does the \H on my screen mean? So you don't have to have the shell prompt that you're given. You can actually customize it with whatever you want. I could make it be, let's see if this works. Can I make it be the date? I can. I mean, it's kind of weird, but I can. So what do I do now that I have broken my prompt? Well, since we haven't put anything inside of a dot file, we can simply exit. And when we log back in, we'll get the original shell prompt that we had before. So for experimenting with that PS1 thing, I recommend that you do it from the command line so that it's not sticky, meaning that you're not stuck with it when you log in every time. But if you happen upon a PS1 that you like, then the way to make it sticky is to put it in one of your dot files. Probably .bash profile is what you'd want at this stage. All right. I think this is really cool stuff. I am excited because it is fun to share with you the ways that you can get more speed and power out of the shell. Command history being the big one, but also the ability to kind of preload your environment with your own personal preferences in terms of customizations. That's where we're headed with this. So hopefully some of you will try that out and like it. But it is fun to do. It's fun to know that I can actually make within the limits of text something exactly to my likings within the limits of text. Okay, it's 9:04. I'm going to stick in just a minute or two break so that people can find this in the video. And then when I come back, I'm going to install window managers and show off demo a few window managers on this system. So if you're able to stick around, I appreciate that, and beg your patience when we come back, because I'm going to do this live and in real time so that you can see the whole process. And some of them have downloads. I experimented with all of them yesterday and they went fast. So I hope that it is still true today that the download part goes fast. So yeah, when we come back, we will switch to the other part of the agenda. So just, it's 9:05 on my computer clock, so 9:07, just 2 minutes of break in there, and then I'll come back. Let us all stretch our legs and do some window manager stuff. Okay, so just enough there to make it easily found if people are watching the live stream later or want to come back to this part. And also maybe you had a chance like I did to get up off the chair for a moment or get water. Okay, so the discussion last week was about window managers, and the only thing I'll say is kind of starting this off is that window managers and desktop environments are different. So if you are a Mac user or a Windows user or an Ubuntu user for that matter, you are accustomed to working in a desktop environment. So a desktop environment is all of the stuff. It's graphics. It has a bunch of built-in applications. It has a docking mechanism at the bottom, and it comes with a clock and a calculator and maybe a notepad program. So desktop environments are graphical environments in your computer, pictures and buttons and windows and all, with extra stuff added along with it. Ways to customize, with backgrounds and change the theme, those kinds of things. That's a desktop environment. That's the bigger thing. A Windows manager is mostly simply about literally managing windows on the screen. It gives you the ability to run programs in Windows and shift those things around on the screen so that you can view multiple windows with multiple programs running inside of them. So they are mostly about just the basics of how do I put windows on the screen to have a very sort of bare minimum graphics environment. They do allow you to do things like run web browsers, so that's an upside to them. Some Windows managers will include a couple of extra little goodies with them, like pop-up menus and stuff, and we'll see some of that. But when you think window managers, think kind of the bare minimum to do graphics on your screen. Windowed programs with sometimes, the little X and the maximize buttons on the top right, that kind of stuff. So Windows managers are really good for computers that have, for old computers that have less resources. I keep old laptops around because I can do this. So they don't use that much of the computer's resources like memory or hard drive space, but still give you the ability to do a minimum amount of graphics like web browser stuff on your computer. All right, so what do we need to do graphics on this Debian system? I am logged in as my normal user with sudo permissions, which is why I have sudo in square brackets. If you don't have sudo permissions, then log in as root to do this stuff up to a point. So I'm going to use sudo, and the first thing we should do before we ever install new software on a Linux system is to use its package manager to update the database of available software. So I'm going to do that first. There's an upgrade package. There wasn't yesterday an upgrade package. So I guess I'm going to have to change my little notes here and go ahead and apply the upgrade. There was not one yesterday morning, but there is one today. So let's go ahead and do that. Sudo apt upgrade will libxpat. So whatever that is, I'm going to go ahead and bring it up to date. All right, thankfully it was very small. So to run any kind of graphics in a Linux system, you have to have the software packages that do graphics on a Linux system. So Windows managers by themselves can't actually do the graphics part. They need other software to support the graphics. So what we're going to use is Xorg. When you see X at the front of something in a Linux system, that's usually related to something graphical. So we are installing a whole bunch of software to support graphics on my virtual machine. And I say a whole bunch because it is a whole bunch of stuff. For me, it's 247 megabytes of download. So you may not want to keep going. If you want to kind of watch, that's okay. Or if you want to keep going, either way is okay. So I'm going to go ahead and say yes, and I'm going to wait that out for a second, which, I say a second, hopefully not for very long. The download part's going fast. I can see a bunch of X stuff going by, which tells me that's all kind of graphics related software. I saw some fonts going by. There they go. Okay, so I don't have graphics. I can do graphics now, even though I don't have a specific graphics system to use. So now that I can do graphics, I can explore a specific graphics system. So I'm going to try Blackbox first. It's one that I like. So I'm going to sudo apt install Blackbox. This is a window manager. It is a small amount of download, less than a meg. So that went in very quickly. And now we have, oops, clear. Now we have to do a little bit, if it's on line 38 of my agenda, we have to do a little bit of environment manipulation. So turns out that there's a dot file for doing the graphics stuff. It is called xinit.rc. The X there on line 38, that's related to doing graphics. And then init, initialize, RC is usually referring to resources. But anyway, and the tilde is my home directory. So make sure I'm in my home directory. I'm going to use VI to create x.xinitrc, which is where I will specify my graphical preferences for this system. Now, before I do that, by the way, backspace, let me make sure that I know where Blackbox is on my system. All right, so on my system, Blackbox was installed on user bin Blackbox. I need that to configure my graphics system. All right, so now let's go to .xinitrc. So we're gonna in here say exec/user/bin/blackbox. I'm also kind of walking you through a setup, which I hope will make it easier for you to try out and then switch back and forth quickly between different window managers. So exec, E-X-E-C, space, /user/bin/blackbox. This is the way that the graphics system that we have installed works. We download the graphic software, Xorg, install it. We download and install Blackbox, which is the specific window manager we want. We edit our .xinitrc file to say that when we start a graphics, we want to run Blackbox as our specific window manager. I'm going to write and quit that. And now from the command line, we type start X, and what start X automatically does is it finds that .xinitrc file and then combines that with the supporting graphic software to launch a window manager. So here is Blackbox. I like it because it's easy for me to understand. So there's nothing here, at least it doesn't appear there's anything here. But what this typically means is that there might be like a mouse button combination that will do stuff. So we'll first try the let's try the left mouse button and see if anything happens on the desktop. Nothing. How about the middle mouse button? Okay, the middle mouse button allows me to move between workspaces, which Windows now has and Linux has had for a long, long time, and also Mac since they became a Unix-based system. So workspaces, which we'll experiment with here in just a moment. That's the middle button. I'm going to left click, turn that off. I'm in workspace 1. I can see if I right click, then what happens? If I right click, I have a kind of a quick access to at least one piece of software that I can run, which is a terminal. So xterm. And then let's see if the window manager actually lets me do stuff like move the window around, resize it. I should be able to right click out here in the space and start another one. That's all the window manager really is. But I can also I can switch workspaces here. So I'm going to use the arrow to switch to workspace 2. I'm going to open up an X term and put this here. Go back to workspace 1 just to show you how the workspaces work. Right, so there's the void was here workspace. And then we get the bonus material. Well, let me go kill that one on the workspace 2. Go back to workspace 1. I'll kill the spare. The bash RC loaded. So this is where bash RC becomes super, super, super handy. We're already logged into the system, which means when we started up our graphics environment, our profile settings didn't come with us, but our RC settings are available to us when we launch a terminal in graphics. So going back to the first half of the live stream, for us in the short term at least, the value of .bashrc is that allows us to carry our customizations into our graphics environment so that when we launch a terminal in our graphics environment, we pick up our customizations. And then I'll try to remember we can tie those pieces together, but for now, let's not overcomplicate things. Just notice that when I launched this terminal, bash rc executed. So that's important because bash profile didn't execute when I launched this desktop, this window manager environment, because I was already logged in. All right, so there is Blackbox. I like it. I find it easy to use. It's a simple right click to get at Xterm. And there are other X-based apps on here probably already if I use tab completion. Yeah, there's a bunch of stuff. So I'm going to, there's an Xcalc. There's so let's try Xcalc. So yep, there's a calculator in here. I can kill that. Oh, by the way, just as a quick review, when I run Xcalc from this terminal, I lose the command line. So what you would do is you'd run Xcalc from here, and then you'd background it, which allows it to still run, and then it gives you your terminal back. So here's a place where backgrounding is actually super useful because I can have my terminal available and the calculator. Okay, so let's get out of this one. Yeah, so if I right click it, I get the exit option. All right, so I'm back in my command environment. Let's try ice. Apt install icewm. It's 100 meg, so it's not tiny either, but I'm getting decent internet, so hopefully this works out. Okay. Now I'm going to go change in my home. So I'm going to update my xinit rc. And instead of deleting Blackbox, I'm going to insert hash pound or pound sign it. This disables the Blackbox line. And then I'm going to use YY on that line to yank YY. And then P to put. Now I have a copy and I can go change this exec one. And I think it's just user bin icewm, but I should have checked. Now I'm going to have to check that. So I've disabled Blackbox, but I still can come and re-enable it and disable ice for the experiment. So this time I'm going to try icewm when I start my graphics environment and see what that looks like instead. Let's go ahead and make sure that I got the right choice for where icewm is. I did. So start X, which will launch all the supporting graphics software and ICE window manager. All right, so here's ICE. I can see that it is pretty similar. It's got workspaces, but they are accessible by buttons. It's got a little start menu down here. And it has a slightly more substantial start menu that managed to actually load in more options in terms of applications and stuff. There's Xcalc. Anyway, I'm just looking around. Are there any games? Follows the mouse. And then the terminal. Okay, so the terminal is at the top of this little menu. So that's good. It's got some funny little controls on here. Oh, yeah, that's neat. So you can see that ICE has actually got a little bit fancier than Blackbox. The other thing to try is, can I move windows around? Can I resize them? What happens if I left click on the desktop? Nothing. Middle click on the desktop. Workspace controls. And a list of everything that's running. So that's kind of cool. Can I kill that from here? And then finally right click and I get the same applications menu. So IceWM is fancier because it comes kind of prepackaged with some additional controls. Can I exit if I right click on the desktop? Is there, okay, not log out. I don't want to log out. I want to exit ICE. Let me click on this one. Log out. Okay, let's see if log out actually logs me out, or does it just... thanks, that one kid. Have a great day. I'm going to finish this thought, so it'll be here if you care to look at it later. So log out. Okay, log out didn't actually log me out of the whole system. It just dropped me out of ICE. And then the last one, let's do i3. So sudo apt install i3. It's a lot less downloads, so that's good. Okay, we'll see where i3 is, user bin i3, thankfully, in our home directory. So let's go change the X init. So I'm going to disable ICE and black box, yank, P, and then I'm going to set up i3. So this way, if you try different window managers, you can just go to your xinit RC file, change the entries, and experiment with different ones. Okay, so write and quit. And now we will start X. And this will happen if you try i3. So do I want a config? So yes, I'm going to press enter. Do I want the Windows key or the Alt key? I'm going to leave it on the Windows key. That's the Windows key on your keyboard. But if you use the arrow, you could change it to be the Alt key on your keyboard instead. I'm going to use the Windows key. So here's i3, and it is a lot less feature-packed. So I wrote some notes for you to help you get started with it. It is a lot harder to use because you don't have the mouse in it. So if I want to open a terminal, I'll hold down the Windows key and press enter. And now I have a terminal. If I want to run a program, I will hold down the Windows key and a D. Now this is handy because across the top, it tells me what's available to me. So let's just see if we can fire up Xcalc again. X, C. All right, and it's highlighted, so I'm going to press enter, and I think it'll launch Xcalc. So what i3 does is it automatically partitions, so you can't move the windows around because your mouse doesn't work other than clicking buttons, but it will kind of automatically space things around. So how do I exit a program? Probably I click on what do I want to exit, the calculator, and then I will do Control Shift Q, and that did work. Can I Control Shift Q on the terminal? I cannot. Interesting. It won't work. Anyway, so this one, i3, is a lot more intimidating. I'm sure I can type exit here and still be in i3. Yeah. So Windows key, enter, I'll open a terminal. And then I'll just, from the terminal, type exit. Okay. So anyway, it's a lot harder to use, a little bit more confusing. What if I do, hold down Windows, Shift E. Yeah, and then I get this little banner that says you're about to close out and go back to the command line. So I'm going to say yes to that. And then I'm not going to do it because closing in on 9:30 here. So I've gone over quite a bit with the demo part. But anyway, you can try installing X11 apps, which gives you a few extra goodies, I think, like Xcalc. You can try installing Chromium, which is a web browser, and then you can use that in a graphics environment. And then I have a note there because someone in chat recommended Qtile, which I really wanted to use, but Qtile, the whole process of installing Qtile was installing a lot of extra kind of things. So I figured it might feel a little bit overwhelming to do Qtile, even though it looks really cool. So I wanted to do Qtile, but I thought it was better to just stick with this selection of them. Oh, I didn't do awesome. Let me do awesome, and then I'll shut up. So anyway, let me do awesome. So you have to install awesome. So yes, it's bigger, but these aren't taking me very long, so I can show it. Make sure I know where it is. Open up my xinitrc file, disable i3, and then try awesome. And then start X. And here's awesome. It actually comes with a little configuration with a cute background. It's got workspaces. I wonder if this is a start menu. It is. So there's a start menu at the top left. If I left click on the desktop, nothing. If I middle click on the desktop, nothing. If I right click on the desktop, I get the menu of things. So it didn't find as many of the applications as ICE did. Can I resize this? Floating, maximized, pinned, on top, close. So anyway, there you go. There is awesome, which is kind of cool. I got to play with this one. I haven't played with it before. Okay, right click. Where was quit? It's in the awesome sub menu, quit. Back to my regular terminal, and that is it. So anyway, sorry again about Qtile. It had a whole bunch of extra pieces I would have had to install, and I knew I was going to run pretty long anyway. So, but hopefully for those of you who stuck around to watch that bonus content, if you're interested, now you've seen me do it at least, and you have a sense of what window managers look like. They even kind of have some that are, very, very bare bones to somewhat easier to use, kind of a spectrum there. We'll do a desktop environment or two later in the semester as well. So that's it for me for this week. Thanks for watching all the way to the end. If you got to the end, I hope that you were able to do some experiments and succeed in them. Otherwise, please have a look at the distribution project, Canvas Inbox, Piazza, office hours as always, and I will see you on Monday next week. Have a great week.